Okay, guys, coming to finish this practice test, hopefully. So we did 22 of them, so I'm going to go to question 23. Which I thought we did question 23. I must have just like typed it in. So we had 3.3943, comma, 6.0305. Next. All right. Here we go. Determine the amplitude, range, period, and phase shift. So this is good because we probably should go over one of these. Okay, so 2 sine of 3x minus pi. And this is number 24. Okay, so my amplitude is 2. The range is going to be -2 to 2, because you always use your amplitude. The period, so for period, you always use 2 pi divided by b. So for this problem, b is 3. So our period is 2 pi over 3. And I don't have these notes with me, so I hope I'm remembering right. The phase shift is, so phase shift, is it C over B? B over C. This is right. So C, remember C is supposed to be negative. So this is actually a positive pi over 3. So our phase shift is pi over 3. Now they're not asking us for your jump, but remember to find your jump. You do your period divided by 4. So here I will be multiplying by 1/4. So it's going to be 2 pi over 12, which is the same thing as pi over 6. So our jump, which is not a question, is pi over 6. So it has our old points up there. Now we just got to do our new points. So I'm going to do the y's. I guess we'll do the x's first. Go in and type all these parentheses. Okay, so you're supposed to start with your phase shift. So that's pi over 3. Then the next one, we would be adding a 6. So pi over 3 is the same thing as 2 pi over 6. 2 pi over 6 plus 1/6 is 3 pi over 6, which is the same thing as 1/2. So right here, it would be pi over 2. Oops. And then 3/6 plus another 6 would be 4 pi over 6, which is the same thing as 2 pi over 3. Right here, 2 pi over 3. Add another 6, so we get 5 pi over 6. And then finally, one more 6 would be 6 pi over 6, which is the same thing as just pi. Right here we have. And then you can double check, because your first one plus your period should equal the last one. So pi over 3 plus 2 pi over 3 equals 3 pi over 3, which is pi. So we know those are right. Okay, and then the second ones you just multiply times a. So 0 times our amplitude 2 is 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2, again, is 0. So there's our y. So make sure you remember these, your period, your phase shift, and your jump, how to find those. Okay, now we got to pick the graph. So we just got to see which one does it right. So let's see, pi halves and pi are the ones we probably should look for. So to me, it should be, oh, I put a 20 right here. Okay, so to me, it should be smaller. So I would think either this one or this one. So if this is 2 pi, this in the middle is pi. And at pi, it's supposed to be 0, which it does, but it's supposed to be coming from negative 2. So negative 2 to 0, this one kind of works. I didn't plug in negative 2 right here. All these mistakes. And then this one, pi is right here, but it would have been coming from positive 2. But this point right here goes from negative 2 to 0. So I need it to be going from down to up. So I think it's this one. I'm going to just zoom in and check. So if this is pi halves, and at pi halves, it's supposed to hit 2, which it does. So yeah, I'm going to go with C. All right, that's that one. Number 25. Determine the specific solutions, if any, to the equation on the interval. So first, we've got to get them all the same trig function is equal to 1 minus sine theta. Right, well, one of our Pythagorean identities is sine squared plus cosine squared equals 1. So let me write that over here. So if I want to solve for cosine, I could just subtract this. So cosine squared is the same thing as 1 minus sine squared. So this, I'm going to substitute for this one. So 1 minus sine squared minus sine squared is equal to 1 minus sine. Okay, so then I have moving everything over. This is, I'm going to go on this side, so these will be positive. So this is negative 2. If I move it over here, that's going to become positive 2 sine squared theta. I've got this negative sine theta. And then if I do 1 over 1 minus 1 is 0. Right? So here I could factor out a sine. And I'm left with 2 sine theta minus 1 equals 0. So I'm looking for solutions when sine theta equals 0 and when 2 sine theta minus 1 equals 0. So that's when sine theta equals 1/2. Okay, so first this one, when sine is equal to 0. So sine is the same thing as y. When is y 0? Well, y is 0 right here because it's the 0.10, and right here at negative 1, 0. So that's at the angles 0 and pi. So we got those two answers. When does sine theta equal 1/2? Well, that's one of our perfect triangles. And 1 is opposite of 6. So right here, it's pi over 6 angle in quadrant 1. But it is also, sine is also positive in quadrant 2. So that's the same angle as 5 pi over 6. So these 4 answers are our solution. So 0, comma, pi, comma, pi divided by 6, comma, pi. And there we go. 26. All right, find the exact value of secant of negative 9 pi over 4 without using the calculator. So where does 9 pi over 4 lie? So we're counting negatively. So 4, 8, 1 more would be 9. So that's in quadrant 4. Cosecant goes with sine. All students take calculus, so cosecant is negative in this quadrant. The reference angle is pi over 4. So we're looking for the negative because cosecant is negative in quadrant 4 of cosecant of sine of 4. So it's B for that one. And then we just got to write what it is. So I know my answer is negative. Right, so we got 1 square root of 2 pi over 4. So cosecant of pi over 4 is hypotenuse over opposite. So it's square root of 2 over 1, which is square root of 2. But because it's in quadrant 4, I know my answer is negative. So negative square root of 2. All right, 27. Let's see if I can fit it right here. Okay, tangent inverse of tangent of pi over 3. What is the value of the inner function? So 5 pi over 3. This is 3 all the way around will be 6. So it's going to be in quadrant 4. All students take calculus. I know it's going to be negative. So tangent of 5 pi over 3 is negative. And if we come back up here to our pi over 3 triangle, tangent is opposite over adjacent. So it's going to be square root of 3. So now they're asking us at what angle is tangent equal to negative square root of 3? Well, obviously 5 pi over 3, but that's not in the interval we can use because remember, tangent is defined right here, which is negative pi halves to pi halves. So what else could this angle be but in that interval? Well, negative pi over 3 would be the angle because over here it was 5 pi over 3, but they're the same angle. So right here, the answer is negative pi over 3. Right, there we go. All right, it wants us to find the angle between the two sides of the roof of the A-frame. So 28, it's wanting us to find this angle right here. I know this is 21 feet, this is 21 feet, and this is 19 feet. Okay, so we're looking for this angle up here. Since we don't know any of the angles, we have to use law of cosines. So remember, c squared is equal to a squared plus b squared minus 2ab cosine c. But this is what we're looking for. So I'm going to rearrange this formula. Okay, so c squared minus a squared minus b squared divided by negative 2ab is equal to cosine c. I think your notes say something different. Like I'm pretty sure these are positives and this is positive, but that's the same thing. Okay, I just do it this way and I rearrange it in my head instead of memorizing the other formula. Okay, so here c squared is the 19. So on my calculator, I'm going to put 19 squared minus 21 squared minus 21 squared divided by negative 2 times 21 times 21 is equal to cosine c. And I'm going to put the top and the bottom in parentheses. So my thing is in radians. You probably can't see that. That's where we left off. So make sure changing it back to degrees. Okay. And then open parentheses 19 squared minus 21 squared minus 21 squared, close parentheses, divided by negative 2 times 21 times 21 equals that. And now I'm going to put it in the cosine inverse to find the angle. So it says 53.79 and it wants us to round to the nearest tenth. So C is equal to 53.8. All right, 29. And the value of cosine of tangent is 1/5 and secant is negative. So you got to draw it. Okay, so I know tangent is positive and secant is negative. So that means my triangle is in quadrant 3 because tangent is positive. Okay, here's your theta and tangent is opposite 1 over adjacent 5. But this is on the negative y-axis and the negative x-axis. So both of them are negative. And now we just have to find hypotenuse. So 5 squared plus 1 squared is 25 plus 1, which is equal to 26. So this is the square root of 26. And cosine of theta is adjacent, negative 5, over hypotenuse, square root of 27. All right, number 30. Okay, the polar coordinates are given to determine the rectangular coordinates. So remember, x is equal to r times cosine of theta, and y is equal to r times sine of theta. So our r is -2, and our theta is 4 pi over 3. So first of all, oops, I didn't put in sine, sorry. Okay, 4 pi over 3 lands right here. All students take calculus, so both of these are going to be negative. So I'm going to do a -2 times negative, and -2 times a negative. Okay, and then pi over 3 is square root of 3, 1 and 2. So sine of pi over 3 is square root of 3 over 2, and cosine of pi over 3 is 1 over 2. So here the negatives cancel, the 2's cancel, you get +1 for your x. Negatives cancels, the 2 cancels, and your y, you get square root of 3. So my answer is 1 square root of 3. And you can kind of, oops, double check this too, because the polar coordinate, -2, 4 pi over 3. So 4 pi over 3 is right here, but because it's negative, it flips the point to be over here. So it'd be in quadrant 1. And this point, 1, positive square root of 3 is also in quadrant 1. So make sure that they're in the same quadrant and you kind of know you did it right. All right, number 31. Okay, so we did the sine graph and the cosine graph and the tangent graph. So now they're asking us for the sine graph. Okay, so sine goes through the origin and is positive. So C, just double check it. Yep. Okay, and then just answer the questions about it. Is it an odd function? Yes. Is the range -1 to 1? Yes. Is the y-intercept 0? Yes. Are the zeros of the form 2n plus 1 over 2 pi? We're in it. So plug in 0, or you can plug in 1, whatever, it doesn't really matter. We can plug in 0. So if I plug in 0, I get 1/2 pi. So it's pi over 2. Is that a 0 of the function? So pi over 2 is right here. This is pi. This is pi over 2. No, it's a maximum of the function. So your answer for that is no. Right, 32. So we're looking for 7 pi over 3. So where is 7 pi over 3? So we go 3, 6, 1 more, 7. It's in quadrant 1. And everything is positive in quadrant 1. Your reference angle is just pi over 3. So now I'm looking for cosine of pi over 3, positive version. And cosine of pi over 3, we use this, is 1/2. So cosine of 7 pi over 3 is 1. Oops, I switched it. Oh, let's do that. Be careful that you don't do that on your test. Okay, 33. I think I can fit that right here. Okay, if the acute right angle and cosecant is square root of 5, find the other values of the remaining trig functions. Okay, so cosecant of theta is square root of 5, and I know technically it's over 1 because it's supposed to be hypotenuse over opposite, right? So sine is going to be 1 over square root of 5. I'll automatically know that because it's the inverse of this guy. Okay, but we got to find the other ones. So I would just draw it here, right? I know this is square root of 5, and I know that opposite is 1. So what is 5 minus 1? 4. Doing Pythagorean theorem. And square root of 4 is 2. So I know this other one is 2 right there. So now I know that cosine is 2 over square root of 5. Right? And I know tangent is 1 over 2. So then these are opposites. Secant is the opposite of cosine. So this is going to be square root of 5 divided by 2. And cotangent is going to be 2 divided by 1, which is 2. Four. Find the exact value or state that it does not exist. So it's asking us to find tangent of cosine inverse of 1. So this is asking you at what angle does cosine equal 1? Cosine is the same thing as x. So where does x equal 1? Right here. That's the angle 0, right? So now basically we're looking for tangent of 0. Oh, okay, wait, let me plug this in. So this is equal to 0. So this is the point 1, 0, right? And tangent is supposed to be the y over the x. So 0 divided by 1 is also 0. So right here, it's 0. But for instance, if we were to land up here or right here, so I'll just use this point because it's not in the way. This is the point 0, -1. And tangent is sine over cosine. So it would be -1 divided by 0. You can't divide by 0. So that's an example of where it would be undefined. If that makes sense. Okay, but our answer for this one is 0. Okay, so suppose the terminal side of the angle alpha is in quadrant 1 and angle B. So we're going to have to find the exact angle of alpha over beta. So give me just a second so I can make sure I pick the right formula. Sine of alpha plus beta is sine cosine with a plus in the middle. Okay, so sine cosine with a plus in the middle. This one. So that's our formula for that. So now we're going to draw them. So it says alpha is in quadrant 1 and beta is in quadrant 4. Okay, and it says sine of alpha is 12 over 13. And then sine of beta, cosine of beta is 3. So down here's 3 square root of 11. Okay, but we got to find the side length for that one and this side length for this one. So 13 squared minus 12 squared. Is 25, so square root of that would be 5. So that one is 5. And then 11 minus 9 is 2. So this is square root of 2 for that one. And because this is going down, it's negative square root of 2. So now we can plug in our formula. I'm looking for sine of alpha, cosine of beta, plus cosine of alpha and sine of beta. So sine of alpha is 12 over 13. Cosine of beta is 3 over square root of 11. Plus cosine of alpha is 5 over 13. And sine of beta is negative square root of 2 over square root of 11. So 12 times 3 is 36. And technically it's a minus 2 square root of 5 because of the negative there. All over 13 square root of 11. So, oh, they can't ask for that. Sorry, guys, I want the extra step. So we want this one, and you literally just got to plug them in. 12 divided by 13, and 3 divided by the square root of 11, plus 5 divided by 13, and negative square root of 2 divided by square root of 11. So I want an extra step. They might ask for it, they might not, but this would be the final answer. All right, 36. A 12-inch pizza is cut into various sizes. What is the area of the pizza that was cut with the central angle of 38? Okay, so this was way back in lesson 1. Let me see. I remember arc length was r times theta, where theta has to be in radians. Is it 1/2 r squared times theta, maybe? That might be. Ariel, let me just look it up. I'm going to pause the video, look it up, make sure. Okay, I'm back. Yes, that is correct. But hang on, I lost y'all because my phone is dying. Okay, so I mean, technically it's theta r squared, but same thing. Okay, so our r is 12, so we've got 1/2 times 144 times theta, but remember our thetas have to be in radians. So 38 degrees times pi over 180. What does that equal? 38 divided by 180 is the same thing as 19 pi over 90. So 144 divided by 2 is 72 times 19 is 1368 pi over 90. Let me see if that can be simplified. Yep, 76 pi over 5. So that's our answer. Oh, it says round to decimal places, so I can go ahead and multiply that out. So multiply that times pi, and I got 47.75. So if it asks for it in radians, you would type in this. If it says to round, you type in this. So 47.75 squared. Okay, determine the amplitude. So that's the A in front, 2. Oh, y'all just love these. Put A equals 2. 38. Okay, so these are our functions. We got cotangent theta over cosecant theta minus 1. Hang on a second. Okay, sorry, I was getting a phone call, so it cut me off. Get me back up here. All right. Okay, so I would rewrite in terms of sine and cosine usually. Oh, no, that's not what they did. When you look at it, you can see they're multiplying by the conjugate. So the conjugate is always opposite. So cosecant theta plus 1. Cosecant theta plus 1 should be our first step. So I'm already eliminate A and B because these put minus 1s at the top. So it's either C or D. So let's see what would happen next. Well, when I multiply these two, I would get cosecant squared theta minus 1 over there. And then the same thing up here, cosecant theta plus cosecant theta plus 1. So what's important is to know I should have a minus 1 down here because -1 times +1 is a -1. So that eliminates D for me. So then I can go to secant. This is a Pythagorean identity. So it equals cotangent squared theta. So basically one of these cancels with this one. And then we have this on top of that. So C is our answer for that one. All right, we write the expression as 1 as the 6th trigonomic one. Okay, so we got sine of 5/2 theta, tangent of theta. So these are called cofunctions, I believe. These, and I'm pretty sure sine goes with cosine. So this is the same thing as cosine theta. And tangent is sine theta over cosine theta, right? So my cosines cancel. And I'm left with sine theta. Okay, number 40, this is one of the lessons we recently did. Okay, so I've got R is equal to 2 plus 5. So it's one of the weird circles, if you remember me calling it that. And so you got to find A over B. So 2/5 is what we got right here. Okay, so if it is less than 1, but positive, it's a lemma with an inner loop. Okay, and because it's cosine, it's going to be symmetric on the x-axis, which is the line theta equals 0. Whoops. And because it's positive, it's got to be on the positive x-axis. So I accidentally clicked A, but I'm supposed to have a loop. Hang on, I'm just moving this so I can see the other one. Okay, so I would assume D because it's the only one that has a loop, but I want to make sure that my points are on the right spot. So 5 plus 2 is 7, and it looks like it hits 7. Okay, yeah. So our answer is D. So lemma with loop. All right, 41. Okay, let me make this bigger so y'all can see my scratch work. Come on. All right, use information to determine the length of the bridge. So we basically got this triangle. It's a right triangle. I know that this is 72.8, and I know this is 40 meters, and it wants us to find x. So I have opposite over adjacent, so I've got to use tangent. So tangent of 72.8 is equal to 40 over x. Since I'm solving for x, these two switch spots. So x is equal to 40 divided by tangent of 72.8. And I'm just plugging that in my calculator. And I got 12.38. Right, 42. Identify the type of graph of the polar equation. So I just got R equals with no adding or subtracting. That means it's a circle. Okay, and because it's cosine, it's a circle centered at the x-axis, which is the line, this one, the line theta equals 0. So circle at theta equals 0. The same thing as the x-axis. Remember, centered at the pole means origin, centered at the origin. Okay, rewrite as an identity. So 43. I've got sine squared theta minus secant squared theta plus cosine squared theta over negative tangent theta. So my Pythagorean identity, sine plus cosine squared is 1. So now I have negative secant squared theta plus 1, or the 1 could go in the front, over negative tangent theta. Well, secant squared plus 1 is probably tangent squared theta. I just don't know if it's positive or negative. So let me look that up just real quick. I'll pause the video for you. Okay, I looked it up, and this is it. 1 plus tangent squared theta equals secant squared theta. So if I have a secant squared theta negative, that means it came over here, and the tangent came over there. So those two switch spots. So that means the tangent is also negative. So that means these two negatives are canceling out, and this is canceling with one of those. So we got tangent theta. Right, 44. Okay, use a sign of the sum of two angles formula to find the exact value. So it's asking us to do sum. So alpha plus beta, we just did this a minute ago. So it was sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. I'm pretty positive, just double checking. Yeah, sine of alpha, cosine of beta, cosine of alpha, sine of beta. Yes. Okay, so what two things can we add together to get 7 over 12? So I would do 3 and 4 because they can both simplify. That's the same thing as pi over 4 plus pi over 3. So this is my alpha and this is my beta. Okay, so I'm looking for sine of pi over 4 is 1 over square root of 2. Sorry, my phone is dying. Cosine of pi over 3 is 1 over 2. Plus cosine of alpha is 1 over square root of 2. Sorry, I don't know why I wrote square root of 2 right there. And sine of beta is square root of 3 over 2. So then I have 1 plus square root of 3 over 2 square root of 2. Sorry, it got crazy in my house for a minute, so I was a little bit distracted on that one. But I hope that makes sense. This was alpha and this was beta, and I was just plugging it in to that formula. So right here should have 1 plus square root of 3 and 2 square root of 2. Okay, 2 more. Okay, 45. Use it to rewrite. So I got tangent of theta, cosecant squared of theta, and cosine squared of theta. So anytime it's all multiplication, rewrite in terms of sine and cosine. So tangent is the same thing as sine theta over cosine theta. Cosecant squared is the same thing as 1 over sine squared. And then cosine squared can just say cosine squared over 1. So this one cancels with one of those, and this one cancels with one of these. So I'm left with cosine theta over sine theta, which is the same thing as cotangent theta. And the last one, what is the radius? So it gives us the arc length. Remember, I wrote that a second ago. So S is equal to R times theta, where theta is in radians. So 30 degrees is the same thing as pi over 6. Okay, so we don't know R, but I know that the arc length is 442 pi is equal to R times pi over 6. So if I'm trying to solve for R, I'm going to multiply by 6 over pi. So that goes away, and R, the pi's go away. 6 times 442 is 2,652 miles. That's your radius. 2,652 miles. Okay, so let's double check. We answered them all. Yep. Just gonna make sure this one's saved. Yeah, 46 complete. Submit test. All right, we did pretty good. We missed a couple, so let's look. Question 2. Oh, oops. That was my bad. I put in the angle instead of the value. The pi over 4 answer was supposed to be down here. Question number 7. I put 12 over 11. It's in quadrant 2. Yeah, it's supposed to be 1 less if it's in quadrant 2. So I guess I just added it wrong. 21. I'm pretty sure I just drew my angle wrong in that one. That's the one where I was like, I feel like I'm doing something wrong. So let's see, 21. Here it is. Okay, I answered 23 over square root of 3. It was supposed to be cosine of 210. Square root of 3 over 2. Yeah, the square root of 3 is definitely supposed to be at the top because it's cosine. So I just wrote that wrong. So here was my mistake. It was supposed to be square root of 3 over 2. And I know I was doing something wrong because I knew that the denominators were always supposed to be the same. That was 21. Let's see, 23, we totally missed. Okay, so I just totally did that one wrong. But I think when I worked it, yeah, it changed it. When I exited out of the test, because mine was negative 0.25, so it changed the problem on me. It was a different problem from the video when I worked this one. Okay. So this is still right. It just changed the problem on me because I exited out of the test and came back. 31 is the range of the function. Negative 1. Oh, it's, oh, they tricked me right there. They got, the answer was no because they didn't use brackets. They're supposed to have brackets right there, and I didn't even notice that. So double check that on your finals. And then the last one, 36. The area. Okay, so I definitely, oh, I know exactly what I did because right here it says the diameter is 12 and I did it as the radius is 12. So I should have used 6 instead of 12 on that one. That's what we did wrong. So little mistakes, they will definitely try to trick you. Just double check. And that's it, guys. Have a great day.